before we start with the lesson today, I'm going to start with this. You understand this? What does it mean? Huh? Yeah. Of course, in Malay, because we use the same word, right? Ikhlas. So, ikhlas. We don't translate it to be something else, right? But if I ask you an honest question, how many of you come to this class with this intention, with this kind of mood? That does not any class. Okay. Throughout the lesson, right? Throughout the lecture, is it important to be in class?
Yes.
Why? Yes. Why? Is there any reason? Is there any problem if we do not have a class?
Yes.
Yes. What's the problem?
No.
No barakah. Okay. Now, if I ask another question, will it be different for you? Meaning, will you act differently if you have a class or not?
Yes.
For example, how different?
From our behavior.
Itu sama dia. Kita tadi tak jawab tahu. Attitude.
Behavior.
Behavior. Meaning, if you don't have a class, you'll jump up and down. Nampak? Kamu tak nak jawab soalan tak masuk. Serius. Now, okay, this is what's interesting when the door is here. Anyway, okay, when you do something for the sake of Allah, right? Okay, let's imagine you have two options, right? I have the option to do A and B, and you know Allah prefer or Allah want you to do A, right? If you are ikhlas, will you ever do B?
No.
Is it possible to be doing, for example, I know Allah wants me to do A, but I do B for the sake of Allah. Is it possible? Allah asks us to obey our mother, for example, right? So I have the option to obey or not to obey. And I choose not to obey, ikhlas lillah ta'ala. Is it possible?
No.
It's not possible, right? Because if you know Allah wants you to do this one, if you are ikhlas, if you do for the sake of Allah, for sure you will do that one, right? It's not possible to do another one. Except if you are how to say? Boleh what is it? Ya Allah, meaning you thought, for example, you thought Ayah Pin is the true prophet, for example, right? You know, this is what Allah wants. Meaning that is, you are being fooled by misinformation, for example. Then it is possible for someone to be sincere and do the wrong thing. For example, you can say Christian thought God really want them to do that thing. Right? So they are sincere, but unfortunately they have the wrong guidance, for example, right? But if you know this is the guidance, so it's impossible to do other things, right? Now, so the implication is, in the class, for example, right? If you do not understand something, do you think that Allah wants you to ask question or just keep quiet? Is it possible to keep quiet and still be ikhlas? It's not possible actually. No, I'm keep quiet for the sake of, because why do you keep quiet normally? What's the reason? Shy, it's mainly your ego, right? Nafsu lah, malu lah, segan lah. So it's because of that. It's not because of Allah, right? So if you are ikhlas, truly you will say, oh, Allah wants you to understand, right? Etc. So you will ask. So when I say the implementation of that is things like this. Normally we don't talk in that sense, but that's the manifestation of ikhlas actually, right? Oh, Allah wants me to understand. So that's the in my hand, etc. Right? So another thing. Are you familiar with this? Subhanakallahumma wa bihamdika asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Familiar with this? What do you call this? I think normally in Malay, I'm not sure elsewhere. We call this tasbih kifarah, right? Is it the same elsewhere?
Yes.
No. Are you familiar with this? At least no.
Yeah.
What do you call it? Is it has a name? Okay. Yeah. Okay. Normally, when do you recite this? At the end of class or session or majlis or whatever. Why? Hmm? Yeah. Do you know, is there any reason other than the teacher teach you to? Do you ask any reason why the teacher asked you to do anything? Okay, if I ask you, is this from Rasulullah SAW? Tak tahu kan? Kau yakin aja kan? Alright, so now there's a real effect if you know why and you don't know why, right? Okay, one of that is it's a long hadith. So basically, so at the end of the assembly, at the end of the majlis, Rasulullah SAW, at the end he says, basically this is translation of Subhanallah wa bihamdik, right? And then someone asks, why do you recite this thing, right? So that also already indicate that when the Sahaba do not understand, they ask, is this for something? Is this just for you or for us to follow, etc.? And what's the response? Wala kafaratun lima yakunu fi al-majlis. Right? So that's where the name comes from. It is kafarah for whatever you have done throughout the majlis. Kafarah, you understand? Basically, it's kafarah for your sin, right? Meaning you have done, meaning throughout the majlis, you say to your friend, this is lecture, it's so boring, whatever. Or you, meaning something that is not a positive thing. So this becomes the kafarah, meaning that menghapus dosa sepanjang majlis, right? So if you know the understanding of this, right, meaning you recite that, the intention is, oh Allah, forgive me for whatever I've done throughout the majlis, right? Does it impact the way you recite it? Ke sama je? You understand or not? Meaning, you know, that recitation is, the purpose is for Allah to forgive us for whatever we have done. If you know that is the reason why you recite it, is it possible to recite it different way? Okay, I've been reciting the tasbih from my school years, and normally what we do is meaning when we are waking up, right? But if you understand what we are asking, right? It's like you go to the lecturer, right? You ask for help, right? Yes sir, but while playing with your phone, for example, right? Tolong rasa. Is that the way you ask for help, right? So if you understand what you are asking, the way it will be different, right? Meaning it will be more serious and sincere, etc. Right? So this is one of the things that I think many of us, I'm not sure about elsewhere, but many of us Malays do many things, many good things without understanding why. It actually affect how we do it. Right, unfortunately. Alright, so and something that is also interesting. I think this is more in Malay culture. Pernah dengar tak macam kita tak buka nak tutup? Dia kata ni penutup majlis kan? Tapi kita tak buka lagi, tak payah tutup kot. Pernah dengar? Tak pernah? Nah, sebab it's like opening and closing, right? But this kafarah is not the closing of majlis, this covering of your sin, right? Tak buka pun kita nak tutup juga dosa itu tu. Alright. Anyway, so that's just for your implementation, inshallah. In all, so it's not just for how to say, like say majlis agama lah. It's for any majlis actually. We still do some wrongdoings throughout the session, so we hope for this. Alright, so hopefully that will become your practice throughout your life lah. Alright, so okay, just for the sake of those who miss it. Okay, for those who missed the briefing session, the recording you can find if you go to YouTube. You just search my name. Yes, I put it there. Go to this one here, and then you can find this basically this playlist here. MCECH 1301 Statics Semester 1 2019-2020, and under that you have, this is before, you have also the briefing session. There are some things that I mentioned there. Maybe one thing that I have to just mention now is the marking the meaning you have 50% from your final exam, 30% from your midterm, and 30% from quiz. And the policy is you have to pass your final exam to pass your course, etc. So there's a lot of things. We do not have time to repeat that because of lack of time. So you can refer to that. And I also mentioned several things about what is important for this course, including trigonometry and integration. So if you want to see whether you need to revise or not on your skill on this one, please refer to all those videos. Right, it's available. So make use of it. Get them up. So we will start with chapter 1, inshallah. Okay, okay, bismillah. So chapter 1, basically you don't have that much content actually regarding to the course, but you have basically a refreshing of some things that you have learned before, and normally you will use throughout the course without realizing it, perhaps. Right? It's many some small things that cover across the section. Right? Okay. Firstly, it's about the course itself. What is mechanics? Before we go to statics, what is mechanics? Because this mechanics statics actually, and then mechanics dynamics. Right? It falls under mechanical domain. Right? This course. So mechanics is basically a study of what happened to a thing when a force or many forces apply on it. So the thing normally we refer to it as body. That's the technical term, right? So anything, right? For example, this is something. There's monitor here. If I push it, what happens to it? So basically that's the understanding what is mechanics. Right? So we call that body, meaning that is one body, right? So yeah, it can be big or small, or what type of shape, etc. All those things can be considered as body that we study, or what happened when force acting on it. Right? Now, under mechanics, there are several branches. So based on the object itself, right? So the simplest thing is rigid body. Rigid body meaning something that basically many of these are rigid body. It doesn't change shape, right? It's rigid. That's the simplest thing. When you have deformable, it will be more complex because when you push, it deforms, so the reaction is a bit more complex. Fluid is the most complex because it flows, right? So to analyze it is very complex. Of course, for those who are from mechanical, either automotive or aerospace, you have to cover everything. But I think most of you, or almost all of you, are not from mechanical program, so you will cover until here. Mechanics and dynamics, right? You have to take these two subjects. The difference is statics is when I push it, it still doesn't move. Dynamic, whenever it starts to move, I will not move this. But when it starts to move, then it's next semester. Not when it's moving. Hopefully next semester lah. Janganlah repeat banyak sangat. Right, so this is what you cover this semester. Meaning when the object is still stationary before it moves. Right. Alright. And all of this basically you have learned in physics before, I believe. Right? So this is the four fundamental physical quantities. You have length, mass, time, and force. And then you have also learned before the Newton's second law, right? F equal to m times k. Okay. In terms of unit system, we will be using SI in this world, I think you know there are two unit system exist, right? And most of the world use SI, where you have kilogram, meter, etc. Right? But kilometers. But if you, I think most of us that have some experiences watching something from the US, right? So they use inches, feet, pound, etc. Right? So that's a different system. Okay. So and I noticed also some students actually they have some reference or textbook that they get from the senior that is using that system, like pound, feet, etc. Right? So make sure you understand the difference of the system. Even the concept is the same, calculation system is the same. But do not, because they are so familiar with pound and feet, inches, when they answer final exam, suddenly the question is in meter, they answer in pound and feet. So that make sure you understand the two different things. Alright, so this is how it is connected to each other. So I think you know the basic unit. For length is meter, for time is second, for mass is kilogram, and then force is Newton, which is kilogram meter per second square. This comes from m times E, right? Now, so I believe you know this already. Also, there's no such thing as plural. Like, it's not 1 kilogram, 5 kilograms. There's no such thing as that thing. And when you write, okay, maybe I should mention this. The way you write have a certain way, especially in engineering, because it can, if you write wrongly, it can mean different things, right? And in terms of examination in this course, your mark is not directly related to how much you understand. Can you accept that? It is actually related to how much you are able to translate what you understand onto the paper. Because what we evaluate is the paper. We do not interview you, right? So even if you understand fully, but the way you write, people cannot understand, your mark will be affected, right? So there's a difference. For example, if you write meter second, and what is this? This millisecond, right? So it's totally different in terms of meaning. When suddenly you get something like, for example, like this, right? You cannot say, but sir, it's just one dot. Why is it affect so much marks, right? But that one dot makes a different meaning, right? So we just assess you by whatever meaning that we understand from the paper, right? So make sure you have a correct habit of writing from the beginning. Right? So that's an example. Okay, so you know this already. So exponential also you know, right? When you have unit and unit, you can become square. Okay, in terms of this, make sure you understand when we say centimeter, meaning this centi or millimeter or kilometer is basically 10 times power of something meter, right? So do not make weird mistake like this. For example, 1000 centimeter. 1000 is 1 kilo, right? Suddenly 1 kilo centimeter. This doesn't make sense. There's no such thing because kilo and centi is basically 10 times something. So do you understand this? Because in the final exam, some semesters back, some students still do things like this, which is this doesn't give a good impression. Meaning that kita tak layak jadi ini macam tu lah. Okay. Compound phrases should not. Okay, this is the point. Okay. So you should know by now what is giga, mega, kilo, milli, micro, nano, etc. What else? So this is we can just do fast on this one. Okay, we have to have dimensional homogeneity. Dimension has to be the same both sides of equal sign. Now, again on the point of how you write will affect what is the grading will be. When you write something equal to something, what does equal sign mean? Yeah, it should be the same, right?
Yes.
So okay. Later we will cover about, for example, you know already scalar and vector, right?
Yes.
You know they are different.
Yes.
So when you write, for example, here you have some scalar, here you have some vector, then that's wrong. it cannot be equal. That's an example, meaning that that statement is problematic. In terms of unit, etc. also, right? Okay, what else? Okay, another thing about this one, right? When you write something like this, let's say F equal to M A, right? And then you write something like this. What does it mean? What do I understand to be here? So we understand it follows, right?
Yes.
Now, this is what happens if what you mean to do is, for example, you do F to M A, and then M equal to F over A, right? For example. But if you forget to write this one, how will I understand it? I will understand it like that, right? If you forget. So do not be surprised if you make mistake like this, you lost a lot of marks. Because from the understanding point of view, it doesn't mean we can assume you forget something, but we can only assess based on what's on the paper. We cannot judge your intention or your heart or whatever, right? Okay, so make sure we have a habit of another thing, some students when they do the final exam, they do not have a structured. For example, the way we read is from top to bottom, right? In the paper, when we follow the equation or number. Some students when they write something like this, right? For example, they get something here, and then they continue here. Whatever. So from us, we follow here, it doesn't make sense. How did you get this? Meaning it doesn't follow. So all of those things, when you do exercises, it doesn't matter because you are the only one trying to understand what you write. But when you give the paper to someone else, it should make sense to them also. Right? Okay, use an appropriate number of significant figure. You know about significant figure? Understand, right? 3 or 4 the final answer, for at least 4 for intermediate application. At least meaning 4, 5, 6 or more. Right? So do you understand? Intermediate calculation meaning throughout the calculation, it should have 4 or more significant figure. The final answer should be only having 3 and not more. Anyone understand why? Okay, why do you need more significant figure when you calculate? More accurate, right? Meaning that if from the beginning you round off, when you calculate, it can have more and more error, right? Especially you multiply, then the error will be too big, your final answer will be far off. Right? So do not round off too early. But why the final answer, normally in the textbook and the slide, they only limit to 3? Anyone know why? Why cannot you put the answer like 3.56, 1, 2, 3, meaning a lot of significant figures? Well, is it a problem? Because it's more accurate, right? From our perspective. So why is it a problem for final answer? Do you think? Any guess? Okay. Now, you have to understand that this kind of course is preparing to be an engineer. It's not just for you to be able to calculate things. There's two different things. Now, okay, imagine this. I ask you to go back and weigh yourself, and tomorrow give me what is your mass of your body, right? So if someone comes back and says the weight of my body is 85.32146 kg, is that a problem or not? Not in terms of overweight, in terms of his answer. No. Why yes? It may change. What do you mean the math will change? After you eat, then okay, is it logic? Okay, how many of you can go back and weigh yourself and get that kind of number? Why not?
Because the scale.
Yeah, in the real world, there's no such scale that can give you that kind of number. You understand? So in the real world, we will get 3 significant figure because that's what we can measure. There's no such thing as a measurement that can go to that kind of significant figure. Right? You understand? So if you are in engineering world and you give number like that, people will that of course when you calculate, it gives you that number, but you have to round off to have a meaningful number, right? So that's where, in terms of engineering world, people can judge you whether you are just knowing how to calculate on paper or you actually have a understanding of the real world, right? Okay, rounding off, I think you know how to round off, right? Okay, skip this one. Okay. Problem solving strategy, IPA. Ada IPA ni? Ada IPA ni apa tak ni? Setengah IPA ni nama ni. Okay. Anyway, so we have three-step approach. IPE is basically the interpret, plan, and execute. Right? Now, this is applicable for any engineering problem basically. Right? So when you have a problem, the first step is you interpret the problem. What is okay, read carefully, of course, in terms of you study and in the exam, right? You have a question to be read. But in the real world, you have to just see, observe, etc. Right? Read carefully and determine what is given and what is to be found. That's two things. Meaning, any question that you go for your quiz or exam, make sure you clearly understand first. Okay, what is the question? What information the question give? What the question want in the end, right? Make sure that it's clear first. If anything not clear, ask and ask, right? Especially in final exam, if you're not clear, do not spend your time to calculate yet, because you might spend half an hour calculating the wrong thing. So just say, is this question, what does this question mean? You can ask that. You cannot ask how to calculate. They will just say, no. If me, I will just say, okay, I'll teach you next semester. But if you ask, am I correct in understanding this question deeply? If you misunderstand the question, I can correct you, right? So make sure you do not waste time, doing something wrong. That's in terms of exam, that will be very, very crucial. If not, if necessary, make assumption. Now, this one does not. Okay, when we say assumption here, not in the case of understanding the question. It's not like I don't understand the question and I don't understand the question. I just assume the question means. I'm not. It doesn't make. It is not in that way. This one is in certain problem. It is impossible to solve unless you make certain assumption first, and then later you have to check whether the assumption is right or wrong. If it's wrong, you have to repeat the whole thing. So in the later chapter, there will be many questions like that. In the early chapter before midterm, normally the question is straightforward. It's just one way to solve. But in the later chapter, the question is more complex, where you have to assume, check, calculate, check if the assumption is wrong, because there will be several assumptions possible, right? Or it can be this. If this is an assumption, the calculation like this. Check. Oh, not correct. Repeat here. It will be. Have you learned programming, bro? It's like if else thing, right? Or if this, then this is how to calculate. Else is like that. You have an iteration. And indicate them, right? So when you have assumption, you have to assume in the exam you have to say, I assume this. Right? You cannot assume the examiner just to assume what you are studying, right? And then plan. Think about the major steps that you take to solve. Think of alternative creative solution. Okay, this is again will be very crucial for the later chapter also. In the initial chapter, normally the way to answer is straightforward. But in the later chapter, there will be like 2-3 possible ways to solve. So it's important to think first for a minute what is the possible way and which one is easier, which one is difficult. Because there will be question in the exam where if you take this way, it will take 1 hour. If you take this way, it's half an hour. So it's important to first think what is possible solution, right? And then carry out your steps. Use appropriate diagrams and equation, estimate your answer. Avoid simple calculation mistakes. Reflect on and then revise. Okay, you understand that? Now, this reflection point I think is important also, especially to detect glaring errors. Okay, for example, the question is like this. Okay, we have like a river here, and there's some elephant we want to transport to this side, from this side to this side, right? We create this ship or this raft or something, this design. What is the maximum weight of elephant that we can carry on this raft? For example, that's the problem. and then you calculate, you say, okay, the answer is the maximum weight is 1.5 kilogram. Okay, is that the problem?
It's not logical.
Yeah, it's not logical, right? You should be able to get, wait, mana ada elephant 1.5 kilogram? It should be that obvious. If you, the way you answer, wow, confidence, then the lecturer will say, okay, you are not fit to become an engineer, because that's not logical. There's no such elephant like this, right? So that kind of things you should be able to do. Meaning you should have the ability to think whether it's logical or not, right? Even if you do not in the exam, right? Even if you know, oh, this is not logical, but you do not have time to actually recalculate. You just say, oh, this is not logical, I know I made a mistake, but no time to recalculate. Even that statement can make the lecturer know, okay, at least you understand what's going on, right? If you, the way you portray is, sir, confirm, sir. Meaning, memang confirm lah, you tak payah. Right? So make sure you this can actually save you for, especially if the mistake is too big, right? If the mistake is minor, sometimes the number is logical but still wrong, so normally that's harder to detect. Alright. Okay. Now, based on what we have covered just now, if you want to calculate, you use your calculator, you get this number, right? 1, 2, 3, 4, 5.6 Newton. What should you write as your final answer? How many of you say A? A. How many of you say B? How many of you say C? D? E? Okay, many of you say D. Why? Okay, now, in terms of the number, this is correct, right?
Yes.
But based on what I explained here, okay, this is why normally if you see the textbook, for example, they will sometimes change the unit so that it will become 3 significant figure. So this is basically the same thing. This can be said as less accurate in a way, but this is more realistic in terms of the real world, in terms of the number that we can have, right? So that's what. Okay, in terms of the exam, sometimes things like this we just tak apalah, baru first year. So we don't finalize that much normally. But this is just to reflect on the concepts. Like that. Anyway, okay, this is just if you memorize, right? IPE, P stand for? Land, alright. So that's the end of chapter 1. But before we finish off and go to chapter 2, just to, you know this game? When I draw and then you have to guess what I draw. Okay, so I have already drawn something. So you can guess what is it, eh? And it is based on what we have covered. It's not outside of the syllabus, right? Okay, try to guess.
Politician.
Bila kita belajar politician lah. Okay, related to what we have covered just now. Yeah, 3 significant figure, eh? Alright? Jadi tak setuju? Itu tak signifikan saya. Alright, so we go into chapter 2 insyaAllah. Now, chapter 2 is quite a long chapter, but at least half of it is something that you should be familiar with already because we have covered it before. But part of and half of it I think is you might have covered also, but it's more tricky in terms of the problem compared to what we have covered before. Right? But chapter 2 is very important because it will be the foundation of for almost every chapter after this, meaning that it will be used, meaning normally in the final exam, this chapter will be embedded in every question. It doesn't have its question on its own normally, but it's basically starting point of every question. Right, so it's important. Right, so it deals with force vector, vector operation, and addition of complementary forces. So, okay, do you know what is coplanar? Basically, it means that everything is on the same plane. Faham? Dia naik capital bangsa nama. No, same plane meaning you know as a plane, right? Meaning that if everything is on this plane, meaning it's two-dimensional. Right? Later on we will go into 3D. So, Koprana meaning 2D basically, right? Everything is on one plane. Right? So we'll start with 2D. Normally every chapter we start with 2D and then we go to 3D. Right? Because 2D you can understand the concept. 3D we apply the same concept but the question will be more complex. Alright. Now, in real application, normally whatever structure that we have is in a 3D, right? Most of the things is 3D compared to 2D. And normally in 3D, it's easiest to be solved by using vector than scalar, right? So that's why we will always learn how to use vector. Even though in some questions that we cover, okay, this is another reminder. Every question that we solve together in the class, in the slide, normally the purpose is just for you to understand the concept. It's not to portray the actual question that will be asked. So normally the question is the easiest type of question. So do not be fooled to think that if you can answer the question or you understand how to solve the question on the slide, you can actually answer the final. Right? It's just to show how to apply the concept. So you actually have to spend some time on your own to try a more difficult question in the book, right? Because that is more representative of the actual question. Right? So make sure you understand that. So because in the question that we give in the slide, sometimes it can be easily used calculate using scalar. So maybe you think that the point to use no point to use vector, right? But in the actual problem, normally if you use scalar, it will be too much of a headache, right? So it's easier to use vector. So that's why we learn about vector, right? Okay. By the way, just to make sure, how many of you have learned about vector before? Tak ada. How many of you have already learned something about vector before? All of you. Anyone who have never learned anything about vector? Right. So this is more of refresh on what is it, right? So, but where did you learn about vector? Is it math or physics or something? Physics. So you already have seen how it is applied, or not? Because some students normally they do not appreciate certain things because it is taught in a way that we just know how to calculate or use, but we don't know how it is applied, right? So it becomes something that you don't appreciate. Kenapa kau belajar ni? Right? What do you learn? Anyway, so you know already, scalar only has a magnitude, and vector has magnitude and direction, right? Now, again, the way you write. In the book or in the slide, now when you write scalar, for example, so for example, force in scalar form, this is F. Vector, how you write? How do you think it is written? Okay, when you write on paper, it's something like this, right? Arrow, right? Or do you learn a different way? Different, what do you want to say? No, everyone uses arrow. Alright. But if you see in the slide later on, or in the textbook, there's no arrow, right? Normally it's written in the bold letter like that, right? But of course, when we write, we don't do this way because one is the waste of ink. There's one. Two is can be ambiguous. I might be confused whether you want to make a bold or your pen is problematic or something, or you are stressful. So now, basically this is the same thing, but this is not the same thing, right? Again, to my point about what you write will affect your mark. So, if your statement here is a vector, right? If it's vector I, J, K. If you write something like this, do not be surprised that you don't get anything. What is the problem? Yeah, you have to have this. You can say, like arrow je se. Ialah markah je pun. Right. Get the point? Okay, so in the slide, they will bold and sometimes they have italics, etc. Right? So normally in our writing, we just have the arrow like that. Right, so this is what I just explained, right? So when you have the bold and non-bold, this is not the same, right? So this is not the same. Your mark will be not depend on what you understand, but what you write on the paper. So even if you understand, but so I understand this is vector, but it's good that you understand, but the mark is based on how you put it on paper, right? So make sure you have a habit of, this one is not a problem if you have a habit of doing, just put the arrow, right? But if you do not have that habit, it's difficult to memorize. Alright. So, okay. Which one is correct? Number one, what is the problem? So there's a difference here, right? What is the difference here? Okay, which one is correct? IJK, is it a vector or scalar? IJK is a vector, right? So make sure you understand those things. But I think for IJK there will be several different ways of writing, right? Which one did you learn?
It's triangle.
It's like this. Okay, so something like this. All of you write like this. Anyone different? Ada bawah ke apa ke tak ada? Because I think I did find out that there are several, from where you come from, there's a different way of saying that is a vector, right? But if everyone say like this, then I just say, okay, when you write like this, you mean vector. If you don't write like this, you mean, I don't know what this means. Okay, the only obvious place when this makes difference is like, for example, like this. 1 K Newton, okay, sorry. K Newton and 1 K N, right? This means different thing, right? This means a vector in K direction, 1 Newton. This is 1000 Newton, for example, right? So that's where the way we write makes different thing. Alright. So in terms of operation, okay, what time? Okay, before because we have two sections here. Some of you we actually have the session until 10 here, right? Meaning 8 to 9 and 9 to 10. And another session which is section what? Section 3. Have it on Tuesday, right? On official time. And I think on Tuesday I asked, and one student have something on at 9. But on Thursday, anyone have any other class at 9? No? Alright. Because in the previous class I did ask, because to cover something, sometimes I extend a bit on the timing for all, so I just want to know what's okay. Alright, you understand this? Yes. Apa yang you understand? Okay, basically this is the meaning of when you say this is vector A, if you have 2A, it's just twice as long, right? If you have minus, it's just the opposite, etc. Right? So you understand that? Alright. Now, all of this, it will not seem to be significant later on, because later on we do not draw that much in that sense. But the meaning is important because when you do the operation, you should understand what's going on in this multiplication. Right? Have you learned about this? Parallelogram or triangle method? When you add vector? Yes? Right, for example, if I have vector A, vector B, right? So what will happen when we do A plus B? For example, C equal to A plus B. What do you do? So if you use parallelogram, it's basically you have A, you have B, then it's parallel, so this become C, right? So in order to do this, you have to actually be accurate in terms of the angle and the length. If you just sketch something like that, or sketch something like that, then it will be a different thing, right? So this method actually requires you to have actual length and actual angle, right? But this is the understanding of addition of vector. It's not the same as addition of scalar, right? So this is another thing. If you write something like this, you understand why I will say this is wrong? Yeah, because the meaning is different. The meaning is, okay, magnitude C equal to magnitude A and plus magnitude B, which is wrong. Because when you add the magnitude, it doesn't become the magnitude of C. It only correct when this vector is equal to this vector and this vector plus. When this vector plus is in this format, right? So the addition of vector and addition of scalar is two different things. Right? So hopefully you understand. Meaning the way you write, the way you put arrow or not will affect your mark. Right? Okay. What if you subtract a vector? If you say A minus B, what happens? Yeah, you just split the B will become the negative side, right? The opposite side, then you add, so it becomes whatever that say that. Alright. Resolution of vector. So have you also learned about resolving vector? Tak pernah tengok. Okay, the concept is just the reverse. For example, if I have vector A and vector B, right? A plus B becomes how? So if you do parallelogram, this becomes C if C equal to A plus B lah, right? So the reverse is something like this. Okay, I have this vector C. I need to resolve into two components, in this axis and this axis. What do? So basically you do the parallelogram. So I become this and this. I mean, it's just the reverse process. You understand?
Yes.
Right. Actually, we have done this a lot, but we don't realize it because normally we done it with x and y. That's so it becomes, this is the parallelogram actually. So this y, this is x. That is the same concept. So even though we already mostly we resolve into x and y, but it is actually possible to do in any axis, as long as you understand the parallelogram. Right? But there's a reason why we do in x and y, because we want to do something else next, right? Which is related to what we'll cover after this. Addition of system of coplanar forces, right? So this is basically the steps of how to add various vectors. Now, as we mentioned before, when we want to add two vectors, we can just use parallelogram. However, what to do if you have to add three vectors or four vectors? Can you use parallelogram? You actually can, but step by step. And then A and B become one, and then C and B step by step. But that's not practical for engineering, right? So that's why we will have another way, which is where we have to resolve the forces, right? So basically the idea, okay. Now, we have covered this one, right? I and J is a unit vector. Do you understand what is a unit vector? Yes? What is it? Represent X. What do you mean represent X? Never mind.
Butter the X and Y.
The direction. Alright. I think we'll have something on unit vector. Anyway, but okay, this is just to say normally the first step, okay. Normally in almost every chapter of this, the first step to solve the problem is normally resolving into X and Y. And Z when you come to 3D. So you have I, J, and K. Right? Alright, so this is how you resolve into X and Y depend on and in some cases X and Y can be at a slanted angle like this, right? Depend on the question. Normally we will face this and this, but sometimes for example, the ground is something like this. Sometimes it's easier to have x and y according to that, for example, right? Normally, it's the same concept, but normally when it's slanting or something, student will get more confused, right? So normally in the exam, we only do that if we want more people to fail. So normally if the midterm is already many people struggle, we don't do things like this. Right? But if everyone scored in midterm, or maybe we should sometimes like that. Okay, so what to do when you have multiple vectors? So basically, if I just to redraw, right? If we have this vector here, this vector here, this vector here, or this vector there. So if you have to add everything, you should have to get all the resultant. So what you do is basically for this one, you resolve to x and y. For this one, x and y. For this one, x and y. For this one, x and y. And then you can just all the vertical and all the horizontal. You just get, for example, this one, and it becomes this resultant, right? So that's why we resolve cost, because when you have everything in vertical and horizontal, or x and y, this one you can just manually add, right? Depend on the direction, of course, positive or negative, positive or negative. So if you get both positive, it becomes like this. If, for example, this one become positive, this one become negative, then the resultant is here, etc. Right? So that's where resolving force is important, and that is where, as we will cover after this, trigonometry is important, because you have to think this is the angle, whatever. Right? So, any questions so far? Good. Yang masa senang sangat saja. You have learned this thing before, right?
Yes.
You boring sebab nak belajar benda baru kan? Belajar benda ni. Okay lah, macam apa sih. Okay, so after that, alright. Now, in terms of your calculation, in the end, the resultant can be like this or any other quadrant. So in the end, you will have the magnitude. For example, in this case, you see FR, resultant force, and you will have the theta, right? For example, theta here or theta there, right? And basically, you should know this already. Right? This is from Pythagoras. This is just trigonometry, right? When you have the triangle, so tangent is this over this, then calculate the theta, right? However, one important thing is when you answer, the answer should be completely clear what you mean in every aspect. So if you just provide the answer of FR equal to something Newton, theta equal to something degree, there's a problem if we do not know theta is where. Where is theta? Right? It can be here or here, right? That is two different things, or any other problem, right? So if you already draw something like this and then you answer, then that's clear. If you do not have this drawing, sometimes they have a representation like, for example, like this or like this. You have seen something like this, just to show it is in this quadrant or this quadrant or something, right? So meaning at the end is something must be there to indicate where is it. Otherwise, your answer is not complete, and you lose marks there, right? Because it's not clear. Even though the number is clear, but where is it is not clear. So that's not a complete answer, right? So make sure. My suggestion is just make a habit of draw this from the beginning, so it's clear already where is theta, right? When you answer after this. Alright, example. Okay, so ready to try some example. So example 1, given. So we have this, and we need given three concurrent forces acting on the 10 post. So this is basically the post. So concurrent meaning everything goes to the same point here. You have three forces. F1 is there, F2 is there, F3 is there, and they give you the angle here. And in this case, one angle is given in this format, one angle is given in this format. Right. Just to check, anyone have any problem to deal with any of this type of angle? By the way, anyone watch the trigonometry video? Is it any problem? Everything understood? I touched on these things, right? Okay. So what needs to be found? We need to find the magnitude and angle of the resultant force. What does it mean? Meaning you should from the beginning, okay, the answer should be FR and theta. Right, that is what it is. So how to do this? Okay, so if normally we find the x component, y component, and then we can add. Now, if we want to express each of the force in Cartesian vector notation, right, in terms of IJK. So let's say F1. What will be I component? 0I. Anyone have any problem with this? You understand why?
Yeah.
So y component?
300.
Okay, you write the way you write, right? I have a habit of doing this arrow, so you write that this thing, right? What? I don't know what it is called. Just indicate that it's a vector, right? So this is vector. What about F2? F2 is here. So minus 450
Cosine
cos
40
45 degrees I
plus
plus 450
sine
sin 45 degrees J. Any problem? Now, I think by now you know already that cos 45 and sin 45 is the same value, right? In the end. However, the way we mark is based on the drawing, right? For example, if you write here sin 45 and you write here cos 45, it will be wrong relative to the diagram because the 45 is at that. Yeah? Even though your answer is certainly be correct, but the method you lose mark here because that statement is not correct. Right? Unless if you redraw it, I'm not sure. Sometimes some students they will redraw and put 45 here because maybe they prefer certain placement, I don't know. But as long as it should be clear what this is based on which drawing. Right? What about F3? X component?
300.
300?
Or like 350.
Ah, what?
315.
3 over 5. 5. And then plus 600 over 5 J. Anyone have any problem with this? Did I cover how to get this in the video? I forgot already what I said. Now, for those who are confused where this comes from, how is it like this, please make sure you watch that video. Now, some students have the habit to convert this into theta first. Now, that have a problem because you can have an error there. Because when you convert to theta, the angle have decimal point. And you run off, and then when you calculate, it can give you a slightly different answer. Because here it doesn't have any error because this is the actual origin. And secondly, I think this is easier actually. You don't have to work at the additional step because straight away just put it. So if you still have trouble to understand how to use this one, please refer to the video. If still not clear, please discuss. Still not clear, please come to me and we can discuss. So what's next? What do we need? We need the resultant for that. So how to get the resultant? FR. So basically, we just add all the x component. Then you get something here, right? And then you get all the y component here. You get something here, right? So in terms of the value, you just see. Then you get this value there, right? 41.8, 1098. What does it mean? It means that okay, x component is 41.8, and then y component is 1098, right? So FR will be here, right? Theta will be here. Oops. So how to get FR in terms of the magnitude?
Square.
Yeah, from the figure, so square root of 41.8 square plus 1098 square. Get the value, right? What about theta? And then we get drawn, right? Now, if you already draw this one is complete. And theta is clearly here. If you do not draw this, then you have to indicate where is theta. It's easier just to draw it. Right? And if you draw to scale, sometimes it can help you if you do mistake. Because if you do, meaning this one is much shorter than this one, so it's obvious that theta should be big, something like that. So it can help if you suddenly do a mistake, then the angle is not logical, so you can check. Right? So that's helpful if you do that. Any questions so far? Any difficulty? Of course, make sure you are consistent, right? For example, in the slide, they use this angle, not theta. So it should be tally. You do not want to say some angle here and then something else here. Then also that doesn't make sense. Okay? Ada yang tak faham apa? Again, I already mentioned in the beginning, trigonometry will be used a lot and a lot and a lot. Things like this. Make sure you understand before next class. Because next class, I think we go to 3D. If you cannot even understand 2D, then it's impossible to follow in 3D because we will use multiple of this. And also this one, right? Okay, so we have another question. Alright? So here we have three concurrent forces given. Concurrent meaning it goes to the same point, right? Okay. Find the magnitude and angle of resultant force. Show the resultant sketch in the sketch. Do you understand the question? Alright, so basically it's the same question, it's the same type of question, we just deal with different forces here. So let's try. F1. What's the x component? This F1. So 8, 5, 0. Over 5. Then? Plus or minus? Minus. This is Newton, right? What about F2?
6 to 5 plus 60.
What's the negative? Minus 6 to 5. Fine. Sine 30. Then? Minus 5 plus F3. Minus 5, 0. Sine 45 degrees I. Plus 750 cos. Any problem where in any place? As you can see, at least from now, this step of expressing force into calculated form normally become the first step in the calculation. And in the later chapter, it's the first step for a longer calculation. So if you have any problem with the first step, even if you understand the other chapter, right? If you make a mistake here, then it's just the mistake will carry out through, and the marks will be affected throughout. Right? So again, I've been repeating this so many times, but make sure you understand trigonometry first and foremost, right? Otherwise, if you make any mistake here, then the rest will just become a sad story of understand, but you make a mistake there. FR, you know what to do, right? Once you have established this one, so you just add all of this, get whatever value there, and then you get all of this, get whatever value there. Right? Positive or negative depend on whatever value that you have, of course. In this case, just go to the answer. You'll get minus 162.8. Here you get also minus 520.9. What does it mean? It means that x formula is to the left 162. Okay, the good news is the concept is exactly the same, 2D and 3D. The not so good news is 3D will be much more difficult to solve. If you don't understand especially, and it takes a little bit longer calculation. Alright, in terms of application, of course, most of our structure is 3D, right? So, you understand that? Now, unit vector, we will just go through in short because we will not use that much of this understanding right now. But anyway, the understanding of unit vector is, by saying unit vector, obviously it is a vector. But the characteristic, okay, if I say I have a vector here, right, and I have the other vector with the same exact direction, but the magnitude here is A, the magnitude here is 1, the vector becomes unit vector of A. Understand? Meaning by characteristic, unit vector is a vector with a magnitude of 1. Meaning what? Meaning when you make a magnitude of this, it becomes 1. Meaning if you have unit vector is blah 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 I plus blah blah j plus blah blah k, right? When you get unit vector magnitude, square root becomes 1. That is unit vector. Now why is it used often? Because if you know something with a magnitude of 1, when the magnitude is 5, then you just 5 multiplied by UE, the vector. Because the vector will just you can just elongate the vector with whatever vector. So that's why you always want unit vector, so that when the magnitude is whatever, you just multiply by that vector. So that's why it is important. Right? So with that, how to calculate is if you have vector A with magnitude A, so unit vector is vector by its magnitude. Right, so that's how we calculate. Okay, obviously this will not come straight away here, but in the later subject. But so we will go into more detail on this afterwards. So IJK is actually a unit vector. Do you know that? Meaning that if you have x, y, z, if you have a vector with magnitude of 1, the vector is, if y is j, if magnitude 1, vector is I. So that's why when you have 5, then become 5i. You just multiply that vector. So the same concept goes whenever it's somewhere else. But the easiest one to understand is IJK, magnitude is 1. Okay? So when you do the magnitude, it becomes 1. Right? So that is the meaning. 1 plus. Yeah. Alright. Okay, now the interesting part when we have 3D is you don't have just one angle, because in 2D it can just be either this angle or this angle. Right? There's no way to describe it except for that angle, right? Or this angle. Right? But when 3D, then it involves more axes, right? 3 axes, and hence if you have, okay, let's put it this way. So you have x axis, y axis, z axis, right? Let's say we have something like this. So let's say we have vector here, right? Where if you prolong, so if this is vector, let's say this is A, right? it actually have three components, right? X, Y, Z. Can you imagine this is the X actually? This is AX. This will be AY. And over here will be AZ. Combining become that resultant, right? So it will have X component, Y component, Z component, become something there in the middle, right? Do you know how to relate between this and this? Now, here is where we use the triangle, the trigonometry, right? Now, imagine we have this triangle now. Let's say we have this triangle, where this is the 90 degrees. If you look from top, it will look something like this, right? Yes. Where this is AX. This one is what? This one is this one, not A. It is this one, right? Let's label it A prime, because we don't have something there. Let's label it A prime. What is this one? AY. This is AY, right? From here, right? Can you relate this? Yes. Okay, if we have, let's say we have the angle. Okay, before angle, because this is just related. This is this. So A is what in relation to this one? So AX square plus Y square, right? Now we can take a look also at another triangle, which is this one, where this is the triangle, right? If you look from this angle, we'll have something like this, right? What is this one? Prime. This one? Is that this one? A. How is this A related to this two? A prime square, and then like this. And write it. So A becomes A prime square plus A Z square, right? Suppose A prime is here, right? A prime square is AX square plus Y square. So you can replace here, then it becomes AX square plus AY square plus Z square. This is it. Now this is how this is derived. Then it becomes just A is equal to AX square plus AY square plus Z square. Right? In terms of solving problem, normally we just use this one. You don't have to re-derive. Right? We just use this relationship here. This is just to show how that relationship is established. So you actually have this A equal to AX square plus AY square plus AZ square, square root of everything. Right? Now, it's good if you understand how something is derived, so that even if you forget, you can actually derive. Right? But if you just memorize, also it's also fine in terms of solving the question. Any questions so far? No? Alright. So, now, we have two ways of in 3D. There's one is in terms of triangles like this. Sometimes it's just given as X, Y, Z, where you have a certain vector, let's say A, and then you have alpha, you have beta, you have gamma. Have you learned about this before? Alpha, beta, gamma? Yes? No? How many of you have covered? How many of you have never seen this before? Everyone have seen? So what is alpha? What alpha is? Basically you got AX over A. Have you seen it before? Cos beta AY over A, cos gamma Z over A. This is another set of basically you can just memorize that, right? You have cos alpha AX over A, cos beta AY over A, cos gamma Z over A. This is a mathematical equation that, have you seen this before? Cos gamma. This one, okay, all of this still, okay, we haven't yet covered the static part. This is just to refresh on mathematics. Because we will use the mathematics in statics, right? All this sine, cosine, this is not static, jangan marah static kalau tak faham. Right? So, but okay, this kind of thing might become useful or important when, for example, the question gives you alpha, give you beta, but did not give you gamma. So you must be stuck. How to do this? Unless you remember, oh, okay, if I know alpha and beta, I can use this one to calculate for gamma. And then you put your gamma here. So that's why the mathematics you still have, you cannot do statics without the mathematics, right? So that's how it is. Alright, so if you remember, I'm not sure if you remember unit vector, where is it? What is it? Okay, if you want to calculate unit vector of A, what is it? A vector over A scalar, right? A vector is basically AX I plus AY J plus AZ J divided by A, right? So you do notice it's the same thing? So actually this one equal to cos alpha, this one equal to cos beta, this one equal to cos gamma. So everything is related to one another because this actually describes the direction, this also describes the direction also, so it's actually related, right? So if you know one, you can derive the other actually. Okay, ini tak masuk static ni. Masuk nampak tak? Okay, when you add, the concept is exactly just the same. When you have the x, y, z component, you just add the x component, add the y component, add the z component. It's the same as what we have done before, right? So for example, A is axi plus ayj plus azk, B bxi plus byj plus bzk. When you add A plus B, it's just add these two, add these two, add these two, right? So the understanding, so you understand the concept, right? So let's try one example at least. Okay, the difficult part is not on the additional part. The difficult part sometimes is on this aspect. The question can give you in terms of this, can give you in terms of this, can combine both. So you need to know both to be able to solve, basically, right? Now, make sure you also remember some of the terms that they use. Like for example, coordinate direction angle. Do you know what that is? That's actually alpha, beta, gamma. So sometimes the question, they will never ask, what is alpha, beta, gamma? They ask, what is the coordinate direction angle? Make sure you understand, oh, that is alpha, beta, gamma. Right? Make sure some common terms you actually memorize and you understand. Projection angle, this is actually, you know, projection. So those sine, cosine, whatever, that is projection angle. Alright, okay, let's try. And let's see how we can deal with this kind of angle. And if you have a problem, then you really need to go back and revise on the trigonometry. Okay, first of all, can you see from the right? Okay, given you have two forces, F1 here, F2 here, the angle is given like this. Okay, this is 345 angle, this is 30 degrees, this is 45 degrees. Find the resultant force in Cartesian vector form. You understand? Meaning the end is what is Fr in vector form. So you don't need to calculate the magnitude or angle, just like that, right? So what do you need to do? It's the same process as before. But first, if you can express everything in, you want to draw?
Yes.
Okay, you can draw. You will draw the same thing, right? Except for the hook itself. Okay, now I think in the later chapter, how to say this? Okay, this question is almost free body diagram already, if you understand. Meaning, later chapter we do not have this kind of arrow. We have like a cable or whatever. Then we have to replace this arrow, right? That is transforming from the actual thing to free body diagram. here we are still in a easy part where everything is given already like this, right? So you don't need to actually draw. So the first task is, what is F1 in calculation F1? IJK. What is F2? Okay, in 2 minutes, please try and see whether you can get or you have any trouble before we discuss. Okay, because we have less than 10 minutes before I really have to get through. For F1, what's the X component? 500? 405. What's the Y component? The same. Z component? Okay. Now, okay, when something is drawn like this, right? Do you know what it means? It is actually on the YZ plane. And if you have X, Y, Z, right? It's here. That's why it's drawn this straight line up, meaning it goes from this Y up here, right? What's the S component? What's the S component? 0, right? It doesn't have any X component. It's here, right? It doesn't have any this component, right? But no one actually said. Anyone say 0 that time? No. So that's a problem. What's the Y component? I think you know this one. Z component? Any question, any difficulty? As I mentioned, this should be, hopefully by next week, this should be, it doesn't should, just like just now, how many seconds do you take? It should be straightforward, right? So if you spend a lot of time on things like this, you are quite critically not prepared for the exam, right? Because this should not take any time. What about F2? What is the X component? Okay, this is a bit more. What's the X component? Minus. X component. Okay. Okay. 800. 71 tak? What? Kau tak jawab apa? For 75?
Yeah, because
How do, okay, do you understand what is the meaning of this? Meaning, where is it? Okay, we have the X, Y and Z, right? 30 degrees from X, meaning 30 degrees here, right? 45 meaning 45 down. You cannot add this and this. You understand? It's here, right? What's this component? Okay, what's the value? Anyone get this? No. Plus 100 cos 45 sin 30. Anyone get this? No. Then you really need to revise your trigonometry. 100 sin 45 degrees. Anyone get this? Only pun dapat. Okay. You didn't what? Didn't want to register. Okay. Now, okay. We will. I do advise anyone who is puzzled or what's going on here. I need to draw or something. Make sure you go and watch the video. Did I mention about 3D? You dah tengok? Yes. Tak ada. Tak ada? Ada. Tapi tak ada benda macam ni. Now, okay, of course, if you have done enough exercise, you can do one shot like this. But normally when you start, you have to do the two triangles, right? There's one triangle here, one triangle here. Now, focus on this triangle, the lighter blue triangle. If you look from this side, it will look something like this. Can you imagine?
Yes.
What is triangle? What is this one? This is F to Z, right? When we talk about F to Z, right? What is this one? This is this line, right? Let's call it F2 prime. And what is this? F2, which is 800, right? Anyone even do not understand this? Can you imagine the triangle to be like this? Looking from the angle? Okay, so from this value, what is F to Z? What is the angle? Okay, this one is 45 degrees, right? What F to Z becomes? From this triangle? You should be able to do
Negative
800 sine 45 degrees. Okay, any problem to get this from here? Because even if this is a problem, then that's my question is, how did you get into main campus? Okay, so but you learned this before in Sept, right? Okay, in this triangle there's no positive negative because there's the length, right? But when we put here, it becomes negative because it goes down. But my question in on the value is this one sine. You should understand this, right? This is cos. This one becomes 800 cos 45 degrees, right? So that's why this becomes 800 sine 45. So you should not have this problem, right? Okay, look at the darker blue triangle here, right? If you look from top, how will it look like? It will look something like this, right? From top, where this one is 30 degrees, right? What is this one? F to X. What is this one? F to Y, right? This one. This one is the same as this one, which is Y, right? What is this one? F to prime, right? And we know already it is 800 cos 45 degrees. So what is F to X? It's basically F to prime cos 30, right? F to prime cos 30. Any problem with that? You know this angle? So F to prime is basically this one, right? You just plug in into this one, you get 800 cos 45 cos 30, which is this one, right? 800 cos 45 cos 30. What is F to Y? F to prime sine 30. If you plug in this one, 800 cos 45 sine 30, which is this one. If you have done this two triangle 4 or 5 times, then you can actually imagine this in your head and suddenly you can get this one actually. Right? If you cannot, meaning you haven't done this yet. Right? Please do so. Just take a look at some example. Start with all these two triangles. Make sure you know how to resolve things. And hopefully next class you already have that resolved, because that is purely mathematics. This is purely mathematics, right? It's not statics. Right? Anyone totally lost apa benda ni? Now, if you have any, okay, I'm not sure because some might have some difficulty in terms of color recognition, etc. Right? Sometimes I refer to, because I think most of you can see this in lighter blue, this is darker blue, right? But if you have any problem that you can identify things like this, please let me know, so that we can help refer it to it differently. Okay, so again, before we move to the next class, make sure you go through the trigonometry part and make sure, not just listen, try and make sure you have tried this on your own. Because afterwards, this step should not take, it should be 1 minute, right? Okay, with that, we end the session, inshallah. Sorry for taking your time. Subhanakallahumma bihamdik, asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. If you notice, this is 2.5. We actually not finished with this one. There's a lot more slides. So the content is quite a lot to be covered in the class session. Right? Hopefully next week you are ready and you can go fast for the remaining of the session, inshallah. Assalamualaikum warahmatullahi wabarakatuh.